Today's video, I'm going to be talking about my Arduino application that will calibrate the temperature sensor and then use a round robin with interrupts to capture the temperature of wherever it is in Fahrenheit using the DHT11 sensor. And then what we want to do to test this is first put our DHT11 sensor in the fridge, monitor the temperature until it levels out, and then start collecting those temperature data points for 5 minutes at 10-second intervals. After 5 minutes, remove the sensor from the fridge, put it in a room, and see how long it takes for the temperature sensor to level out to room temperature. Here I'm going to be using 3 applications. The first is our Arduino software, which is just going to be running on the Arduino, and it is going to monitor our DHT11 sensor. Second will be a Python script that reads the serial bus information from our Arduino Nano, and it's going to store that in a CSV file. And then the third script is just a simple code that will convert the CSV file into a plot for us to reference. So here's the Arduino Nano code, and these are the 2 references that I use. The electric, this website was really great for learning about how to use registers for our timer control, and then this is the actual documentation for the microcontroller that is on the Arduino Nano. And so chapter 15 specifically talks more about interrupts and the registers associated with that. So in this program, we are going to be interacting with 3 different types of registers: the timer counter control register, timer interrupt mask register, and the output compare register. I'll explain a little bit later what these mean, but first we're going to have to figure out some values that we're going to set to this. So what we want to do is periodically every 10 seconds read the temperature. However, our clock cycles cannot be triggered on 10 seconds, so I set it for 1 second instead. And so the system clock, or the clock that is on our Arduino Nano, is 16 megahertz, and I'm going to be using a prescaler of 1024, and I'll later talk a little bit more about the prescalers. So to get the speed of timer 1 on the Arduino Nano board, we're going to divide the system clock speed by our prescaler, and we get this value of 15.625 kilohertz. After that, we're going to try and figure out our pulse time, which is just 1 over our timer speed, getting us this value. And then we're going to want to figure out this compare register value. And so to do that, I'm using the time that I want to raise the interrupt, which is 1 second, and I'm going to divide it by how many pulse times are the pulse time. And this is going to let us know how many pulses there's going to be in our system clock until we need to raise an interrupt. So for this, I am using the DHT library. Here I'm just initializing our interrupt enable and disable. And then the library, you have to initialize what pin. So the DHT11 is on pin 2, and then I'm telling the library that I'm using the DHT11 because there's also a DHT22 sensor. And then here also initializing. This variable is very important because it is a volatile variable, which means it is going to be used in our main loop and our interrupt function. And so we have to be really careful with this not to have any shared value or shared variable problems. So this is a Boolean variable called readTemp, and we're going to use it as a flag that is going to let us know when 10 seconds has happened and when we need to read our temperature. I'm doing this because the library that I'm using to read the DHT sensor cannot be used in interrupts, so it has to be read in the main loop. So this is just a setup, and in this we are going to be doing register-based programming. And so in chapter 15 of the documentation for this microcontroller, we know that there are, I think, 2 or 3 clocks. So I'm going to be using timer 1, and this is A and B timer 1. And so before we can do anything, we first have to turn off interrupts and then reset the timer. So we just start at 0, start fresh. And then here, from the documentation on page 110, it goes into more detail on exactly how to set up this register for each value, and I saw that if I wanted to do 1024, I had to turn on bit 1 and bit 3, or bit 0 and bit 2. And then after that, we need to enable our compare match register, which this is basically we're turning on our trigger interrupt. We're going to say that we're going to want to interrupt on a certain value, so we first have to turn it on before we can tell it what value to interrupt on. So by setting this as high, we're telling the output compare register that we want to enable our comparing. And so here, I'm setting it to how many pulses we want before we interrupt on, and then I just turn back on our interrupts. This is a simple function that just reads the temperature, and fortunately the DHT library, if you set it to true, it'll read in Fahrenheit, but if you leave it alone, the default is Celsius. So I set it to true because we want a Fahrenheit reading. In our main loop, we're going to be monitoring that read temp flag, which is our volatile variable set up here. And when it's set to true, we're going to turn off our interrupts, read the temperature, as well as send that temperature over our serial bus for our Python script to read. And then we're just going to want to reset that flag and turn back on our interrupts. So every second, this interrupt function is going to trigger, and we're going to come in here. And the first thing we need to do is reset timer 1, so that way we can stop at 1 second and then reboot to 1 second and just continue in that loop. And then I'm going to increment this seconds variable. And here, we can use the advantage of finding the remainder, which if you divide something using the percentage sign, it is going to be returning the remainder of that value. So seconds divided by 10 returns the remainder. If there is no remainder, it means it's divisible by 10. We're going to raise that read temperature flag so our main loop can handle that. The second application is a Python script that just accesses the serial bus and reads what the Arduino is sending into the computer. So I just use the PySerial library, set up what COM I'm on, and then what our communication frequency is. And then here I just have everything being written to a CSV file. The name is here. And you can see all the data that was collected. And then this is just a pretty simple algorithm to read through it, decode it, split it if there's multiple readings, like if we wanted to have Fahrenheit, Celsius, and so on, we can have that all sent on one line and it'll break that up for us. And then it's just going to write it to our CSV and continue to do that until I disable this. So this program is going to run on the computer while the Arduino software is going to run on the Nano. Lastly, using just the Jupyter Notebook's online application, I wrote an additional simple script that would take the CSV file from our Python script and just plot it on a plot like this so we can see exactly how our variables came in. And so from here you can see at the bottom, this is the 5 minutes that we were in the fridge. And after it was taken out of the fridge, we continued to collect points until it leveled out. So it took approximately 27.5 minutes for the temperature to level out to room temperature. And we know this because there are 195 data points, and it was 10 seconds between each data point, which means it's 1,950 seconds. And if you divide that by 60 seconds per minute, we would get 32.5 minutes. However, we know that we left it in the fridge for 5 minutes. It was taken out at that 5-minute mark, and so it took 27.5 minutes for our DHT11 sensor to update the temperature of the room.
And then the wiring of this is just the Arduino Nano. And then I'm using this DHT11 module. And the ground is just going straight to ground. VCC is going to 5 volts. And then that data line is going to our GPIO pin digital 2.